Let us do question number 5, B, Roman 1. You are welcome. Use partial differentiation to determine the value of dy over dx at the point 0,4 for the function given there. We are required to get dy over dx. We are supposed to use partial differentiation. How can we arrive to getting dy over dx, yet we are doing partial differentiation? Now, let me remind you one thing, that the partial differentiation of z with respect to x, if I divide it by partial differentiation of z with respect to y, if I divide these two, I will get dy over dx. How? Carry dz over carry dx divided by carry dz over carry dy. This one is same as dz over dx multiplied by dy over dz. Now dz will cancel with dz there, and therefore we get carry dy over carry dx, which will be equal to dy over dx. Now let us get the two values, that is the value of carry dz over carry dx and the other value carry dz over carry dy. Now to do partial differentiation, we need to keep one variable constant as we differentiate z with the 1. Therefore, dz over dx, here we are going to keep y constant. Therefore, we differentiate z with respect to x. How are we going to do it? We differentiate x squared, and we are going to get 2x. We differentiate y squared, but y is constant, therefore we get minus 0. For xy, we differentiate it with respect to x, and therefore x will go there, therefore we are going to be left with 4y, and we differentiate 2x with respect to x, we are going to get minus 2. 6y differentiated, we are going to get 0 because y is constant, and definitely 8 is constant, we differentiate it, we get 0. Therefore, carry dz over carry dx, we are going to get 2x plus 4y minus 2. So, that is the value for dz over dx. Let us now get the value of dz over dy. Carry dz over carry dy is equal to, we differentiate x squared, and since x is a constant, so we get 0, minus, you differentiate y squared, you get 2y, you differentiate, that is y squared. For xy, differentiated, remember, x is constant, therefore we get 4x, so plus 4x. Differentiate 2x, it's a constant, therefore we get minus 0, plus 6y. We are differentiating with respect to y, therefore that becomes 6. 8 is a constant, differentiated with respect to y, we get 0. Therefore, carry dz over dy is equal to negative 2y plus 4x plus 6. And now we have that other value there. We want now to get dy over dx. We are going to divide this value, that is carry dz over carry dx. We divide by that other value, that is dz over dy. Therefore, this becomes 2x plus 4y minus 2 divided by negative 2y plus 4x plus 6. And we are told that we get the value of the gradient of the tangent at the point 0, 4, where here the value of x is this is a value for x, and this is a value for y. So when we substitute it here, we get dy over dx is equal to 2, we put 0 instead of x there, plus 4, we put 4 instead of y, so 4, minus 2, divided by negative 2, y is 4, so you put 4 here instead of y, plus 4, you put 0 instead of x, plus 6, and finally we get this is we get 14 over negative 2, and therefore the gradient of the curve at that point is negative 7. The curve in general is looking like this generally. So we are having maybe a curve looking like this. We want this is a point 0, 4, and we are required to get the equation of a tangent that is passing through this point. The equation of any straight line is in the form of y is equal to mx plus c. This equation therefore becomes y here is equal to 4, x is equal to 0. So let us get the value, and of course m is equal to negative 7. This is our value m there, so that one. So let us now work out this equation. We get the value for c. The 4, which is our y, is equal to m is negative 7, multiplied by x is 0, plus our c, and in this case c is equal to 4. The equation of this line therefore becomes y is equal to, the gradient is negative 7, multiplied by x plus 4, and the equation of this line therefore becomes y. The equation of this line here therefore becomes y is equal to negative 7x plus 4. And we can still rewrite it in another way, that is y plus 7x is equal to 4. That is the equation of the tangent that passes through that point, and the point is 0, 4.